All right, class. Here's an example of a problem that you may get for one sample hypothesis testing. Okay? So the question says for a random sample, you had a mean of 83 and you took 625 different values to get that mean of 83. And you're going to assume that you know the population standard deviation, which is 15. So what they want you to do is test to see if it's likely that the true population mean is 80, and it's giving you your alternate hypothesis, which is that the true value is not 80. Okay, and they want you to test this at the 95% confidence level. You can see that by seeing alpha is equal to 0.05, and so 1 minus alpha over times 100% gives you your confidence interval. So the first thing that we can do is draw my picture. And you'll notice if in fact the true mean was 80, that would be in the middle. I'm over here to the 83. And so what we're calculating is the likelihood that it is at least 3 units away and pretty much on both sides. The reason why we know it's both sides is because that says does not equal. So I'm not interested in whether or not it's less than it or it's greater than it. Just if it is not equal, it could be less than or greater than, and that's fine. So we'll write down what we know. Our assumption is that the mean is 80. Okay. Our alternate, now in our last video, I call this HA. Some books actually call it H1 as well. Yours is one of those that's H1. And you have mu is not equal to 80. By the way, this question can be found on page 261, number 10. It's the last exercise of chapter 12. Okay? So then, once we have our hypothesis written, we have to calculate the z-score. Okay? So we do the z-score by z is our value minus the hypothesized value over sigma over root n. Now we're lucky in this case that we know sigma, which is 15. And then we have the square root of 625, which we should know is 25, under 83 minus 80. So we're looking at 3 divided by 3/5, right? Because 15 over 25 is 3/5. So when I bring it up, I actually have 5. All right, so that's huge. And you can check it again if you want to, just to make sure my math is right. Okay, so 15 divided by square root of 625. Invert that, multiply it by 3. It is in fact 5. So a z of 0.5 is what you would look for in the chart to see how much is outside of that. But you don't even have 0.5 on your z chart because it only goes up to like 3.99 because there's so little value outside of 3. Most charts won't give you that. So we can just realize at this point that if I were being 95% confident, I'll straighten this out for you. I know that I need to compare my z value to 1.96. Okay? So clearly, my z value is greater than 1.96, so I will reject my null hypothesis. So what I'm actually going to do is do it this way. My z, which equals 5, is greater than 1.96, which is, if you see this star here, that's basically saying that's your critical value. Okay? So this means critical value. So we reject H naught. And so you can actually have this as a sentence. Since z, which is equal to 5, is greater than 1.96, which is my critical value, we would reject H naught and conclude that the true mean is not 80. Okay? So we would conclude the alternate hypothesis. Okay, if you want to continue, and conclude that that the mean is not equal to 80. Now the second part of this question says, what does this tell you about mu? Okay. What it tells us is that mu is not 80. It could be more than 80. It could be less than 80. All we know is it's not 80. Okay. So that's enough to solve this one question. But that's how you would do it. Number one, if you want, draw your picture, see the area you're interested in. Number two, write down your hypotheses. Okay. It is important that you decide your level of confidence or your critical value, your significance level before doing the analysis. So you don't want to tweak it. You don't want to say, okay, I want to be 99% confident, and then you find that that's not in fact the case. Then you drop it down to 95 and you drop it down to 90 just so you can find a significant finding. That's actually statistically unethical. Okay? So we always determine before you do anything. Right here you see they said, okay, we want to be 95% confident. Then you do your analysis. Then you find your data, you plug it in, and make your conclusion based on what you see. Okay? So that's the first question. The second question of that same is this. For a random sample, well, actually it's the same data, but it says construct a 95% confidence interval for the data. Now, we didn't talk about how to calculate a confidence interval, but it's really simple. If you remember from our first question, there was a value, z is x minus mu over sigma over root n. Okay? The confidence level takes in consideration this mu over sigma n. Can't write today. No. There we go. It takes in consideration this sigma over root n. So to calculate a confidence interval, what you do is have your value, okay, plus or minus your critical value times your standard error, which in this case is sigma over root n. So from here we can plug away what the values are based on what we saw before. So our number was 83 plus or minus 1.96 times times 15 over square root of 625. Okay. We know that 16 over square root of 625 was 5/3, I believe. 3/5. Yeah, 15 divided by 625 is 15 divided by 25, which is 6/10 or 3/10 or 3/5. So I have 1.96 times 0.6, add and subtract it to 83. And so from here I just grab my calculator and plug it in. I'll bear you the gory details. So you'll have 1.983 minus 1.96 times 6 gives me 71.24. And if I added them, this should be 0.6, shouldn't it? So let's do that again. 83 minus 1.96 times 0.6. That's 81.82. So this first one's wrong. 81.82. And the second one, when I add them together, 84.18. So this is my 95% confidence level. How do you interpret that? We would say we are 95% confident that the true population mean is somewhere between 81.2 and 84.18. And I will actually write down the interpretation here. Okay. So, well, I actually want to write in black for some reason. Okay. We are 95% confident that the true population mean is somewhere between 81.82 and 84.18. Okay. So that next question actually asked you, what does this tell you about mu? This is what it tells you. It tells you that the true value is no less than 81 and no more than 84. So consider that. I'm going to make my little bar here. Okay. 81.82 is here. 84.18 is here. And there's some values in between here, right? If you think about our hypothesized value, which is 80, it falls on the outside. Out here is 80. Okay? Since it does not show up in between the confidence interval, there's not enough evidence to suggest it's 80. Okay? So we could use a confidence interval to do our hypothesis testing. And the cool thing about it is if we use the hypothesis testing, not only do we know it's not 80, we also know what side of 80 it's on. We know it's greater than 80 because you see the lowest it could be is 81.82. So if we just did the hypothesis test the normal way, we'd say, no, it's not 80. It doesn't look like it should be 80, right? Our data shows, we did our z-test and we came out with 5, and 5 is much greater than 1.96. 5 is even greater than 2.575. So we're even 99% confident that it is in fact not 80. But when we looked at a confidence interval, we were able to say not only is it not 80, but we know it's greater than 80. Okay? Now this is one example of a confidence interval at 95% confidence. Let's assume I want it to be 99% confident. If that's the case, all you have to do is change this critical value to 2.575 and redo it. So let's do that and see what happens. Okay. I'll push this back up, draw my line, and I am at 80 plus or minus 2.575 times 0.6. This is at the 99% level. Okay, and so I'm going to grab my calculator again and plug in 2.575 times 0.6 and end up with 84.545 here. And on the outside, on the lower part, looks like my battery is dying on me. 81.455. Again, we should notice 80 falls outside of it so that we conclude that there is no evidence to suggest that the mean is 80. We reject our null hypothesis and say, you know what? It's not 80. It's definitely not 80. And we actually know that it's more than 80. So consider that. It says, which approach gives you more information about mu? And the answer, of course, is the confidence interval, because the confidence interval tells you what side of your null hypothesis the hypothesized value shows up as. So this gives you more data. Both of them can answer your question is it or is it not? But the confidence interval gives you a little bit more information and says, not only do I know it's not, but it's actually to this side or to that side. Okay, that's an example of doing a one sample hypothesis test on the mean, assuming you know the standard deviation. Okay. Now, your textbook does not have proportions in here, but on my next video, I'm going to show you how you would do a calculation for proportion. Because believe it or not, proportions, in fact, you know what, I'll actually show you the setup now. Okay. So keep in mind, we have multiple samples. Okay. We have a sample of, we have multiple statistics based on a sample. We can do means or proportion. So in this case, I'm going to look at a proportion. All right. So for the proportion, your null is the proportion is equal to some value. Let's say it's 0.3. And your alternate is still two types, one-sided or two-sided. So a two-sided would say P is not equal to 0.3. This is a two-sided test. But the one-sided test would say P is greater than 0.3, one-sided, or P is less than 0.3, also one-sided. Okay? So again, well, the interesting thing about the proportion is that the distribution of sample proportions is in fact normal, which is pretty cool. So the, sorry about that, the sample proportions are distributed normally with a mean of the population proportion. So the mean value is in fact the proportion of the population, and the standard deviation of the proportions is P times 1 minus P over N times the square root. Okay? So here's an example. I'm assuming that the proportion is 3, and against the alternate that it's not 3. Okay, so we're looking at these two hypotheses. Okay? I collect my data, and I've actually made one mistake here. I need to make sure I stay the same with my terminology here. I'm going to use pi because most books use pi as the population proportion. Okay? So I collect my data, and my data actually is P. And my P is, let's say, 0.4. Okay? And I did this based on N equals 100. Okay? So to calculate my statistic, it is in fact Z because it's normal. It's equal to your value, whatever it was you're interested in, whatever it was you collected, I should say, minus your assumed value divided by the square root of P times 1 minus P over N. Okay? So here I would plug in 0.4 minus 0.3 over the square root of 0.4, 0.3 times 0.7. Some people use P times 1 minus P if you don't have the population proportion. In this case, we're assuming that we know that it's 0.3. So you'd have 0.3 times 0.7 over 100. Okay? So 0.21, you have 0.0021. So the square root of 0.0021 gives you 0.0458. So you have 0.1 over 0.0458. And if you were to multiply that by 0.1, answer inverse times 0.1, you end up with 2.18, which is equal to 2.18. Now here's the key with the proportion. Okay? With the proportion, it's the same Z values. Your proportion, Z, is greater than 1.96 for 95%. You reject H naught. This is at 95%. If it's greater than 2.575, You reject H naught at 0.01 or 99%, and if it's greater than 1.645, you reject H naught at alpha is equal to 0.10. Okay. Now these are a couple of, you might want to memorize these three numbers, 1.96, 2.575, and 1.645. These are the few times when you'll find a z-value that's not on the table. Okay, if you look at your table for a specific, let's say you're looking at the 90% one, you're going to have values of 0.004. Well, you'll have values that are here, a little bit less than it, and here, a little bit greater than it, and your value you're interested in, 90, is like exactly in the middle. So like for instance, you'll see 8995 and 9005 or something like this. And you'll find that your value, 90, would be halfway between 164 and 165. So that's where we get this third decimal place from. But these will be nice to memorize. That way you'd have to look for it. Okay? So on a two-sided test, on a two-sided test, the critical value for 95% confidence level is 1.96. For the 99% confidence level is 2.575. And for the 90% confidence level, it's 1.645. Okay, I'll consider proportions done until class tomorrow or Monday. But in the meantime, I have one more video to show you, and it's actually the one that we should have gotten to first, because most of the times we do not know what the population standard deviation is, so we have to estimate that first. So in my next video, we're going to look at doing a one-sample test where sigma is unknown. That's it. Have a good day. See you soon.